Okay, now we'll study about boundary of roots. Now, when you hear this term boundary, what do you mean by that? So boundary is a point beyond which you cannot go, or that's where it stops. Imagine a cricket match, the boundary is where beyond which the ball goes, it's always 6. So boundary of roots would mean a boundary beyond which you won't have any possibility of roots. So if I say this is my axis, so this is my boundary. Beyond this, I cannot have any roots. And when you remember, we did rational, in the previous class when we did rational root theorem, we got possible number of roots. And if I find for this equation, it would be plus or minus half, plus or minus 1, plus or minus 2, plus or minus 4. So somewhat a boundary is already known to me. It would be around minus 4 to 4. But could I reduce this further? Could I shrink the number of possibilities? So this is given by a theorem called Theorem of Bounds. Now what this basically says is, and for this I urge you to see what you need to know what synthetic division is. If you don't know, I urge you to look at any other video that teaches you that. Alright, so Theorem of Bounds says that if you divide this function and you perform a synthetic division with, let's say, c that is greater than 0, then the number of terms that you get, if they're all positive, then you cannot go beyond that. Let's take an example. Let's see. For this, let's try 1. So I perform a synthetic division on that. So 2 minus 5 minus 6, 4. So 2 minus 3 minus 3 minus 9 minus 9, that becomes 5. So they're not positive. So this wouldn't be, so since I have negative, this cannot be, so this is not the boundary. Let's try for 2. Minus 5, minus 6, 4, 2, 4, minus 1. I don't want to go beyond that because I've already got a negative term, so this won't satisfy. Let's try for 4. 2 minus 5, 6, 4 becomes 2, 8, 3, 12, 6, 24, 28. If I see here, all of them are positive. So that means you cannot go beyond 4. But which I sort of knew before. So this didn't help me much. But let's see for negative side if we can reduce the number of possibilities. C less than 0. So for C less than 0, I'll just name it as A and B. For C less than 0, if you perform a synthetic division, then it should have alternate signs. Let's try out again. Say minus 1 to 2 minus 5 minus 6, 4 becomes 2 minus 2 minus 7, 7, 1 minus 1 becomes 3. This is not alternate, so cannot have this as my answer. Let's try for minus 2. 2 minus 5 minus 6, 4 becomes 2 minus 4 becomes minus 9 becomes 18, that is 12 minus 24, that becomes minus 20. So I see there is an alternate signs. So that means my boundary is shifted to minus 2. So I could have a possibility of roots only from minus 2 to 4. Now a question that might arise is, why am I doing that? I only had these many amount of roots, so this wouldn't necessarily help. And that's true, you don't necessarily need to do this find boundary of roots for this kind of an equation. But imagine if you had, instead of 4, you had 20, and instead of 2, you had 6. Imagine the possibility, the number of possible roots that you could have. At that time, instead of testing all of them, you try to find a boundary in between. You try to find the middle roots and try finding the boundary and see if that help you reduce the number of roots and number of hidden trials that you need to do. So